Okay, so is my screen visible to everyone?
You're good.
Okay, great. I'll get started. So, hello everyone. As Jeff introduced, I'm a PhD student at the IT Security Lab at Virginia Tech, and I'm pursuing my PhD degree right now in mobile forensics. So today, I'm going to talk about mobile forensics, the manual and the automated aspects of it, and how they compare. So, let's get started. Um, Initially, I'm going to provide an overview of mobile forensics, how things work. I'll provide you with a basic process model that is like followed by mostly everyone. Followed by that, I'm going to discuss certain auxiliary models which are followed by different investigators in like different kinds of cases like child exploitation and copyright infringement and cryptocurrency and all those cases. Following that, I'm going to discuss some challenges related to the mobile forensics field. uh, then I'm going to talk about how machine learning is being used in mobile forensics, and then I will discuss the experiment that we have worked on and how manual versus automated forensics or manual versus machine learning for mobile forensics compares. And I would conclude like based on the results from that experiment. We can take questions as we go. If you have any questions, just feel free to chime in and ask, or we could take them at the end, like however you feel comfortable.
I hope that Jeff warned you. That's just kind of how we roll.
Yes, yeah, I've been here before, so I know.
He is
So
prepared.
yeah. Sure. All right. So, like I'm gonna give you an overview of mobile forensics. Basically, like define mobile forensics. It's like as far as NIST goes, it is the science of extracting evidence from a mobile device using certain acceptable methods under forensically sound conditions. So by forensically sound conditions, we mean that the evidence, like if you get to a certain evidence, you must be able to reproduce the methods or the evidence to like that you can get to the evidence again. So reproducibility of evidence is pretty important. uh, Usage of Faraday bags or signal jammers, or probably just getting like somehow getting the device off of the network is one of the conditions that's necessary for forensics so that the data cannot be wiped remotely. We also tend to use write blockers because you don't want to modify user data on a device. So write blockers are really important. Um, Again, like no modification of suspect device data. So these are like certain forensically sound conditions that we tend to follow while performing extractions and analysis of mobile devices. Next, I'm going to discuss the basic forensics process model that almost every investigator follows to get to a certain evidence, or before and after they get to a certain evidence as well. Uh, so mobile forensics is a very non-standardized field, but there are like certain standardizations that everyone follows. So we're going to start with the standardizations and then discuss the various non-standardized methods that are possible. So the first phase of the process model is intake. So like you initiate the procedure for intake, or another agency initiates the procedure for intake. And once that happens, you need to identify the source, or the agency that's initiating the forensic extraction or the analysis. uh, Once you identify the agency, you also identify the questions that come with that particular case. Like, what does the case pertain to? What are you specifically looking for? And that all falls under the identification phase. Right after the identification phase, we have the preparation phase, where we need to identify or try to understand what kind of devices we are dealing with. So once we know what kind of devices we are dealing with, we need to have appropriate technology or appropriate tools to extract those devices. Uh, the next thing is like isolating the device. As I talked about Faraday bags and signal jammers and not letting the device get on the network. Once the device is handed off, it might already be in a Faraday bag, or you might want to like put it in a Faraday bag if it's already not. And whatever state it is in, like hot or cold, like switched on, switched off, or whatever, like you just keep it that way, and then we'll move forward accordingly. The next phase is the processing phase, where you extract the device and you analyze what's going on with the evidence in there, or just try to analyze what's going on. Once that is done, the verification phase comes in. So if you get to an evidence and you feel that like this could be something that could lead to something in the case, uh, you go to the verification phase, where you verify that evidence using different tools. Like it could be open source tools, it could be another proprietary tool that you have access to, and just try to verify the evidence the best way you can, so that you have a defense for the particular evidence that you're looking at. The next phase is documentation and reporting. So whatever you find, you just document it, report it in a way that it can be presented in court, which is the next step, presentation. So you either present it in court, or you present it to your stakeholders or whoever initiated the analysis for the device. And archiving. So the last step is important as well, because throughout the duration of the case, archiving, like we need access to the extraction, and we need to archive the extraction in both proprietary and non-proprietary formats, to make sure that even if we lose access to a certain kind of a tool during the case, we are still able to like use that extraction in another tool, or a non-proprietary format using any other open source tool. So archiving is an important step too. In our experiment, we are mainly going to focus on the processing part, and specifically the analysis part, where machine learning plays a big role. So next, I'm going to talk about certain auxiliary models which are being followed by investigators, and these are only like the documented auxiliary models. There are a lot of auxiliary models that we use on a day-to-day basis, and like you can't call it a model. It's just the way a certain investigator functions. So I call them models because these have been presented in previous papers. So I'm just gonna like briefly provide you an overview of how things can change based on the case type. So like here we have the digital forensics triage methodology with feature weighting. So here the highlight or the difference from previous model, the basic process model, is the feature extraction or the feature weighting. So first of all, these guys are using machine learning for analysis of the data, and they are presenting it with feature extraction and weighting. So when you feed data to a machine learning algorithm, you can either like just feed it raw data and let the algorithm take the decision for you, or you can improve the decision making aspect of the algorithm by adding feature weighting, or that the feature weighting, like if you assign like different weights to different features based on certain like classification categories, you end up with a weighted score. So this model adds that phase in between. uh, Another model is uh, the child exploitation material specific process model, which also includes social and situational analysis in certain cases. So in cases of child exploitation, social analysis is pretty important, because building the social profile of a person who is involved with certain kind of child exploitation is important, because like there are certain things and certain evidence that revolve around that. And again, situational analysis depends on, say, if you're analyzing a device with some material that points to child exploitation, uh, you must verify the situation around that particular evidence. Say a particular image exists, and you're trying to like nail someone down based on that particular image of child exploitation. You must like try to verify how that image got there. So if it was just from the cache and it appeared, it could mean something different versus user created data, like whether the user created that image or the user took that image. So it's really important to like figure out and verify before you go after someone. So that's the social and the situational aspect that gets added to certain models, or certain investigators follow that kind of approach. In the next case, we have the forensics process workflow for pedophilia related cases. Again, similar to child exploitation, but here we are focusing on triage. So, triage generally is fast forensics, or it happens before you try to analyze a certain aspect of evidence from a certain device. So triage is basically you're trying to understand what kind of evidence could be present or could not be present on the device, and that's generally fast forensics. But in this particular case, they took triage to a different level where they collected previous criminal reports, they normalized and analyzed the data, they extracted features from it and tried to classify a device even before it was analyzed. So they took the data and they tried to analyze the data in a manner to take a decision whether this particular device could have pedophilia related content or not. So it's like they do triage using machine learning, where they focus on like eliminating certain devices which potentially may not contain such content and would be a waste of time to analyze. So that's where the triage comes in, and again, it's a different kind of model that's being followed for certain cases. So next, I'm going to move on and discuss certain challenges in mobile forensics. I've already stated some, and I'll reiterate those. So the first challenge is evolving technology, the growing volume of data, and the number of applications that are increasing every day in the Play Store and the Google App Store. So like all of these are issues because every time a new OS comes out, every time a new security patch comes out, extraction thing certain extraction types and certain analysis techniques are going to change. So and that's going to be problematic in certain cases. So because of this changing nature of mobile forensics, it's really hard to keep track, and every time like forensic investigators and researchers need to be on their toes. And again, on that note, like security and encryption, that can be a difficult problem for forensics as well. The other major problem is non-standardized procedures or meta models, like an investigator in cryptocurrency or an investigator working a child exploitation case would be probably following different kinds of techniques, and they may not be the same techniques, and that causes certain issues because there isn't a standardized procedure or a meta model to work on. So based on that, again, like training and educational gaps, uh, an investigator with probably 1 year of experience would take decisions differently as compared to an investigator with probably 4 to 5 years of experience. And I'll prove that when we come there, like when we get to it. Like certain educational or training gaps can cause issues, like it could falsely exonerate someone or convict someone, and that can be an issue. So training and educational gaps are a really big challenge for the mobile forensics industry. um, and again, varied experience levels, I already explained that part. So varied experience levels, again, it's a problem. um, Again, forensic tools and the limitations, certain tools may not be able to get you the full picture, and you do need to have multiple tools for verification. So the limitations of the tools, you need to have a suite of tools to overcome that. So our main focus for our experiment is these three challenges which we're trying to counter using machine learning and getting everyone up to the same uh, like the same level before they take a decision. So like they can take better informed decisions if machine learning is used for analysis initially. So like machine learning is omnipresent these days. Like people are applying machine learning to everything, and mobile forensics is like not untouched by machine learning. Uh, we discussed the DFT model earlier, the digital forensics triage methodology, where we were talking about feature weighting. So on the left, you see that importance of features in case of child pornography. I'm sorry to say that, but it shouldn't be called pornography. It's child exploitation because it doesn't like it's not the right way to put it. But that's how the paper used it, so that's why you see that there. And on the right we have importance of features for copyright infringement. So if you look closely, in case of child pornography, video files and picture files and URLs are the topmost priority in terms of features, whereas in case of copyright infringements it's again like certain types of like certain URL statistics and its video statistics and music for copyright. So those could be different, like the importances of each one could be different and the order of importance could be different. So the point here is that mobile forensics in is very case specific sometimes. Like in case of cryptocurrency and in case of copyright infringement and in case of child exploitation cases, the expertise required from the investigator would be different. So domain knowledge is very important, and if you do not have enough domain knowledge, or if you like if there are new things coming out in the market that you don't know about, uh, that's where the problem lies, and that's where we need to translate that the knowledge of certain investigators into a machine learning model to make sure that the machine learning model takes the right decision every time without like depending on the background knowledge of the investigator. So here next I'm going to show you like the results of this. So this paper, like once they assigned the feature importance, they did feed the data to certain machine learning algorithms. So initially, like before performing feature weighting or before like analyzing the features and assigning importance, they did some baseline tests with with the models they had. So Veka is basically another tool that lets you like run any kind of machine learning algorithms using the libraries and everything that they have set up. And again, they did run some models using C++. I don't remember exactly. They probably ran random forest and decision trees on using C++. And based on that, they presented the accuracy results. If you see that the accuracy is like 56 and 55% in case of child pornography cases, and it is 100% in one of the cases in copyright infringement, and 77 in the other case. But with feature weighting, there were improvements. Like in case of child pornography specifically, there were improvements like 74.8% and 65.2%. So the main point is like feature importance is important, whether you do automated feature importance using Kullback Liebler or you do manual. So how the manual feature weighting works is that you go to an investigator, you assign them a certain set of data with the features in there, and they would pick the features that they think are the most important. So that's manual forensic weighting. And in case of automated forensic weighting, they do like they use an algorithm called Kullback Liebler, and using that algorithm, they try to assign weights. So whether it's automated or manual, the question here is feature weighting. So feature weighting is always better, and this is the basic overview of how people are using machine learning for mobile forensics. So based on this and like mobile forensics in general, I would like to like move on to my experiment, which is manual versus automated mobile forensics. And before I move on to that, like, are there any questions? Okay, so I'll just move on. So so in this case, what we're trying to do is that we're trying to compare a certain data set of cryptocurrency and trying to understand how manual analysis and automated analysis would work in both cases on a particular data set. But we do not have the luxury of comparing them both on the same data set. I would be comparing both the automated and the manual analysis on a different data set, but I'll give you the logic behind it and you would probably like agree. So initially, we created a sample cryptocurrency mobile forensic dataset since there isn't any available. So we are not focusing on the blockchain. We are focusing on a cryptocurrency dataset that is based of a endpoint device or like host-based forensics. So here we are going to consider a sample cryptocurrency dataset that I'm going to talk about in the next slide. On that, we're going to run decision tree analysis using the CART algorithm. Followed by that, we'll evaluate the model using the precision, accuracy, and the F1 score. And then we're going to extrapolate the results of an existing study on child exploitation material, comparing manual versus automated, or comparing the manual part. And then we'll compare the results of the two studies. So I'll dive right into it and show you the data right here. So here on the rightmost column, you see confidence. So and the values for confidence, the possible values for confidence are high, medium, and low. So what we're trying to do here is that based on certain features and certain aspects of mobile forensics, we're trying to assign a confidence value to a particular artifact so that we know that a particular artifact must be looked into in depth or can be ignored, because when in case of mobile forensics, like the amount of data that you get, it's a lot. I'm not comparing it to like computer forensics because that's a different problem altogether, but there is a lot of redundant data that you don't need to go through. And we are trying to eliminate that redundancy or eliminate that data that's not important to a certain kind of a case. And to do that, we need like that certain experience of a particular kind of case translated into a model. So here we are trying to show that based on certain features, we have a certain kind of confidence on like a particular artifact. So I'm going to try to explain each aspect that I've taken into account, like memory, cache, and source type. And if you have any questions, just ask me. So memory means like the hard drive or the physical memory, whether the artifact exists in memory or not. Same thing for cache, like whether the artifact existed in cache or not. Like you can so when you extract and analyze certain evidence, you can see the sources, you can check the sources. If a particular artifact was derived just from the cache, I would probably in certain cases have a lower confidence level on it. But if it was derived from the memory, the stable memory, I would probably place more confidence in it, because I'll at the end of the presentation, I'm going to show you like certain examples of cache where, as we mentioned, like TikTok at the start of the meeting, we're discussing TikTok news. So in case of TikTok, there are two different kinds of caches. One is the Fresco cache, and the other one is a regular cache. So here is where user created data versus non-user created data comes in, because Fresco cache does not contain user created data. It contains data that was cached when the application was fired up or when the application was trying to access the network. So whatever cache was existing on the network would come up like on your device, even if you don't browse through it, it's going to exist on your device. And uh, like that whatever is there in that cache is not user created. And if you try to like nail someone down based on Fresco cache, that's not the correct way. So that's why I have like less trust on Fresco cache versus the other cache, and that's why overall I would trust cache a little lower as compared to a stable memory. So that's where the discussion between memory and cache comes in. And again, it's not just TikTok, it's Twitter and a lot of other applications which are storing different types of caches, and you need to look for user created data. So you should definitely every time verify user created data. Again, source type, what kind of like artifact is it a transaction or an address, or a set of seed words, or to log into somebody's wallet, or is it a log file containing some user data? So based on like the type of the source, I'm going to place like different levels of confidence for each one. uh, Again, in the case of database, it's the source, like what kind of database. Like I don't trust Fresco cache, but I trust the other cache. So based on like where like the file path is, what the file path is, what the endpoint file is, I would like place a different level of confidence on each one. And then extraction type. So like certain extraction types get you more data, but you can like tend to get more redundant data as well, and some of the data might just be populated or parsed by the tool, and incorrectly parsed by the tool. It can happen, and again, like I would trust different extraction levels differently. Like Qualcomm Live, in case of Celebrite, does extract more data. So like there are certain aspects that you can't get to just with a full file system. So with a full file system, you might miss on something, but the Qualcomm Live gets you more data. So I would likely place more trust on Qualcomm Live. And again, like as I mentioned, like the tool analyzes certain data. Like, do I place more confidence on analyzed data, or the data extracted from the file system, like the data that I can see in the file system? So I would definitely place like less confidence on parse data, because verification is really important. You definitely need to use other tools and other forms of verification uh, to verify that a certain artifact or evidence exists. And then the file system, in case of the file system, if I see it in the file system, I would place more confidence in it because I know the source of it. In case of analyzed data, sometimes it may be like hard to prove like where the data came from or populated, or how it was parsed, or what went behind that. So that's why I would place more confidence on file system. And based on all of these factors, I would take a decision on how confident I am about a certain artifact.
Hey,
So
Sahil,
yeah.
how did
How
you
did you
come to
come to
these
these
seven
seven
features
features
Okay.
as opposed
opposed
to
to
the
the
rest of
rest
them?
of it?
Okay,
Okay,
so
so
these
these
seven
seven
features are
features are
like
like
pretty
pretty
important
important
based
based
on
on
what
what
I
I
have,
have,
based on
based on
my
my
experience of
experience of
mobile
mobile
forensics.
forensics.
And
And
this is
this is
not
not
like a
like a
real
real
data
data
set.
set.
In
In
case of
case
a
of a
real
real
data
data
set,
set,
and in case of like when I actually end up doing the machine learning part of real data sets, the attributes would range from probably 100 to 150 to maybe 200 plus attributes. So taking into account those attributes uh, like is really important, and that's the real life scenario. But even in that case, if you like try to look at how the decision tree is taking a certain decision, you would probably end up at certain major attributes that would be affecting the decision making process of the algorithm way more than the others. And I feel that these are some of those attributes that do affect the decision making process.
So when you run that decision tree, do you get like a weighted score on how much the attribute impacted?
uh, Yes, because like in the upcoming slides, I'm going to show how the decision tree was formed and how it bases its decision on
on extract
extraction type. But it is again going to be dependent on the
on the
data
data
as
as
well.
well.
So
So
it's
it's
not
not
just going
just
to
gonna
depend on a certain attribute. Like so, if a certain attribute is can classify a lot of data at one single level, like reduce the impurity in the samples, then that particular attribute will be
will be
given
given
like
like
more
more
value as
value as
compared to
compared
the
to the
other
other.
attributes. So in the upcoming slides, when I show you how I built the tree, like I did not build the tree, but just the mechanism of the tree, then you'll probably better understand the decision making behind these like features.
Okay, thank you.
Sure.
Can you discuss real briefly the extraction types here?
So the extraction types here are like full file system. So in case of full file system, like it's just like maybe a backup of Android. You just like back up your Android. It's kind of like full file system. In case of Qualcomm Live, what I was stating is that Qualcomm Live is a technique, a chip level extraction technique, which basically targets devices with Qualcomm chips, and like it does a chip level extraction, and you get more data out of it. So that's the difference between full file system and Qualcomm Live. Method A and method B are something that Celebrite does. Like they try different kinds of exploits for a particular extraction besides Qualcomm Live. And again, Qualcomm Live is only available for devices which have Qualcomm chips, and that's mostly Androids and Samsungs. And again, chip off. So chip off is basically an intrusive technique where you need to take the chip off of the device and then try to analyze it with like certain different tools. Like so they have sometimes you use the test access ports, the JTAG part, where you hook up with a test access port on the chip and try to extract. And in other cases we need to do chip off, and then we need the right like basically I would say um, like the right mount for the chip, and then like have the chip work with that mount and then try to extract it. So again, I would place less confidence on chip off, because there could be damages use while you like doing chip off. Like if you take the chip off of the device, you'll have to desolder it out, and it could damage the chip or the memory or anything else. And so the data could be modified, or could like what it could be anything. So based on that, I would place like less confidence on intrusive methods versus non-intrusive methods.
So there's a strong preference for full file system
Yes, there is a
exploitation.
yeah versus chip off, or any other intrusive method, or maybe even a stronger preference for Qualcomm Live.
Yeah. Okay.
Yeah, thanks. Okay, so the in case of cart, we are in case of the cart algorithm that we are using for our decision tree, we're going to base it on Gini, which is like Gini impurity. So this kind of defines how impure or pure a certain attribute is. Like so if you see on the left, you see full file system, chip level, method AB, and chip off. So these are potential values for extraction types, and like based on the different samples within the samples that I just showed you, based on that we calculate how pure or impure a certain sample can be, or a certain feature can be. And based on that we calculate the Gini impurity for each of those values. And we just keep it like like for reference in the future, to make sure that those samples are separated out well. Like this right now is showing how much impurity exists within extraction type, and then the next step would be to calculate this impurity for each of the attributes. And once you do that, you need to choose the one with the lowest Gini impurity. So basically what this means is that like having a Gini index of 0.367 for extraction type or the feature is that um, this if you take extraction type as the root node for decision tree, you can classify maximum pure samples in one go. Like if you take extraction type as the root node, you can assume that the left child would end up being a pure sample and the right child would have all of the impure samples. Like that's just a utopia situation. But what happens here, like if you look here, based on the Gini index, the lowest Gini index, we chose extraction type as the root node. And based on that Gini index, uh, we divided, like if you see the left child with 0, 3, 4 values, the left child does not have any high confidence values. So all the high confidence values were separated out in the right child. But because of certain like drawbacks, there were some low and medium in the right child as well, but in the left child there are no high samples. So extraction type was able to like like narrow down onto the high samples and keep them out in one like another space to make sure that the decision making process is better. So based on that, if you see here that the Gini impurity at the first level was 0.653, and as you move down, the Gini impurity is decreasing at 0.49, and at 0.56, the Gini impurity is reducing. So as you go down the tree, it's going to be more and more pure samples, and like we would end up with decisions like based on certain extraction type and the other features, it would eventually end up taking decisions. And that's how the actual extraction the tree looks like, the decision tree. And you may see that certain features have been used multiple times, and that is allowed in cart algorithm. So you can use the same feature to reclassify certain types of um, target values, which is in our case confidence level. So any questions related to this? Okay, I'll just move on. So, based on this decision tree and our sample data, which is just like a self-created sample data, it's not extracted from a device. We get these results for the algorithm. So we are going to look at the F1 score because it is a better overall measure of accuracy, because it's the harmonic mean of precision and recall, and it displays or it shows the results better. So in this case, the F1 score, the average F1 score for high, medium, and low target values is about 0.87. And the reason I had to do an average F1 score was for comparison purposes. So the other study that I'm going to talk about uh, is based on average F1 scores like a unit average for the whole forensic unit. So that's where we took an average for our results as well, and based on that, we're going to compare the two results. So this is the, like, if you see, like, the average is 0.87 or 87% accuracy in terms of classifying whether an artifact must be placed in the high, medium, or low category. And as the data increases, as the amount of data increases, this is going to go up. Like, we just had probably 20 records, and we even had to like split it into test and train. This would improve as there are more data points. And next, we move on to the manual analysis part, where I'm going to describe an experiment that was performed by or taken into account by another paper. And I'm trying to compare like my results with the results of this particular manual analysis paper, so that we can come to the conclusion that in a certain case, in a particular case, machine learning would perform better than manual analysis. So there isn't any existing research or any other paper on manual analysis of cryptocurrency data. So we had to go on to child exploitation data. So in this particular paper, the authors had 5 different kinds of child exploitation material exhibits. There was an experiment controller that was designing all the experiments. There were 4 preliminary analysts with different levels of experience. One was an experienced investigator with probably 4 to 5 years of experience. There were 3 analysts with just basic IT background and just 2 days of informal training. And then there was another volunteer analyst from a non related unit. So, this 4 analyst unit that we're talking about is the child exploitation unit, which focuses on child exploitation cases, and they have domain knowledge. Whereas the one volunteer analyst is from a non-related unit, probably from copyright infringement or from cryptocurrency or any other financial forensics. Then we had one digital forensics investigator to establish the gold standard. So there was this highly experienced person who established the gold standard of the ground truth for these 5 exhibits to compare to. So all the 5 exhibits were run through deep thought, and the results from deep thought from the automated analysis were presented to these uh, five different analysts, like they were presented with the results, and then they had to choose whether they would take certain artifacts into consideration or just like uh, do not no, like not consider them or exclude them from consideration. So that's how they had to give their decision of include and exclude, and based on that, the results are right here. So if you look at the unit average in terms of decision making or in terms of excluding or including a certain artifact, so in our case we have a three prong decision making where we do like high, medium, and low confidence. They had just include and exclude, and even in that case they had a unit average of 0.58, or like you can like say it as 58% accuracy of uh, decision making in terms of artifacts or evidence for child exploitation cases. And that's pretty low because like uh, only a 58% chance of classifying a certain artifact correctly is not right, because somebody's life might be at stake. You might be like exonerating someone falsely, or you might be like convicting someone falsely, and that's not right. So that's why we'll compare it with our machine learning results. Here you can see that analyst 1 with the most experience had the highest F measure, except for analyst 3, which you can consider as an outlier maybe, because there is like the data is so low, like it's just 5 analysts. Uh, Analyst 2, 3, and 4 had lesser experience than analyst 1, and analyst 3 is the only one that shows higher results than analyst 1, and it could be a fluke in a certain case as well. So we'll consider analyst 3 as an outlier, and you can see that analyst 1 has higher F measure than analyst 2 and analyst 4, which proves our point that experience matters and domain knowledge matters. So, and again, like analyst 5, a non-related domain, is way below, like down at 0.35. So if you were not in luck and uh, like your device, if you are in question and your device ends up with analyst 5, you could be screwed up. So it could be a problem. So that's why we're trying to focus on better these results by bringing everyone at the same level and then doing the decision making. So here you see that the unit average for the child exploitation material case, the child exploitation material data was 0.58, and in our case, in case of cryptocurrency, it was 0.87. And domain specific knowledge is very important, and that's why we are promoting like domain specific knowledge, and we're trying to like translate that domain specific knowledge into machine learning, so that you don't have to have domain specific knowledge, and the model can take decisions for you. So here the unit average in this case would go down if domain knowledge does not exist in case of cryptocurrency. Like cryptocurrency is a newer field, and a lot of investigators with their daily activities don't have the time to get up to pace with cryptocurrency. So this manual part would probably like go down, the F1 score for that would go down. Whereas in our case, as the data points increase, like we just did a sample set of like probably 20 records. If we have like 20,000 records, or maybe like say 1,000, even 1,000 records from an extracted mobile device, and we take decisions based on that, our accuracy is going to be up in the 99% range. So machine learning would perform way better if you don't have domain knowledge, and that domain knowledge has already been translated into the model. We definitely need investigators and analysts to translate that knowledge into the model, because right now it's just what I feel that is the correct way to go. Like Jeff asked about the 7 features that I considered. Those are the features that I considered. A different analyst could consider a different set of features, and is that is why we need their inputs. Like investigators need to have like translate their knowledge, and then we like run the knowledge like run the feed the knowledge to the model, and then try to take decisions based on that model. So that's why like we are not trying to like eliminate investigators or eliminate analysts. What we're trying is that everybody can get up to the same point, so that decision making gets better and better justice is served. So
would you say that also needing domain knowledge is important because the domain keeps changing, right? There's different models of Apple, iOS coming out that changes the way that you can extract, the way that you can do things, or
right,
mistakes and bugs that are in each new version that
right,
someone needs to investigate.
right. So like in case of extraction, domain knowledge is good and necessary, but in most cases the extraction would end up with the companies that are making the tools, or like Celebrite and Magnet and like any other companies, and they would do the extraction part and they would keep up with the knowledge. But in case of analysis, you need to analyze what the tool presents in terms of evidence or artifact, and analyzing that does require like knowledge, because if you don't know how to read or study a particular artifact, then that artifact is either going to be thrown away or included. So it's a matter of chance if you don't have domain knowledge. And that's why
Thanks.
analyst 5 with the least domain knowledge performed like the worst.
Thank you.
Sure. So on that note, I would like to conclude and state that automated forensic analysis would work better in certain cases, and in cases of like complex fields like cryptocurrency, they can remove the uncertainty from decision making. Um, and then we do need the like translation capability, like the models are providing the translation capability, but the expert domain knowledge from investigators is still required. And again, we're not trying to eliminate investigators, just trying to make their life easier, even if we can do some data reduction for them, in the way that they don't have to look through maybe 200 redundant records or 200 unimportant artifacts in case of cryptocurrency. Then it would be great. Like they can just probably go through the 20 that have high confidence, and it makes their job easier. So that's what we are focusing on, and we can take up more questions if there are any. Sure, go ahead.
I don't know.
Okay.
I feel like this is how to analyze or how to handle.
Okay.
Right? You got certain artifacts to look for in those logs, or instead of because those logs can, depending upon either security of any one given or group of
Right.
you may generate alert. You similar to what you're what's here is that, look, this is where you don't have all of the artifacts. Look at because of how they're weighted. You look at the important ones, got you all of them, and then something out on the hey, he did find something or didn't find something confident. And
Right.
the analyst would go, could key in on that rather than having hours, days, months, whatever coming through 100.
Right. Right. Makes the combing way easier.
Right.
In in these examples, courses, the
Yeah.
methods of analyzing the all the same.
So
Physical devices in all of the cases.
so the data here was not created using physical devices. It's like a example data. So there weren't any extractions or analysis performed. And like certain aspects are based on experience. Like I can show you certain artifacts. I was about to like pop those up. Shall I, like, do you have questions pertaining to this, or shall I just show you those artifacts?
Sure.
Okay, give me a second.
I was just trying to wrap my head around the methodology and
Of the experiment.
yeah, and the differences and how I don't find the results surprising, right?
Right,
The domain knowledge is very important. That
right,
sort of tracks and makes sense, and I kind of see where Corey is going. That we identify the things that AI is good at and let it do
right,
those things, and then ignore everything else and things it's bad at.
right,
Sure, run it. I don't care. I'm not going to look at the results because it's bad at that.
right, right.
I feel like that's what the whole kind of crux of AI, right? Playbooks.
Right.
All right, what's your playbook for? Well, why can't you tell me? There's too many scenarios. All right, well, first, I don't need you to articulate every possible. What makes you go, ah, that's so
Right.
humans intrinsically, whatever the confidence level is, the analyst is going to have built in through
Right.
the new guy
Right.
is going to have a different confidence level, more experience. I guess this is the whole root of the thing, right? Training the AI based on that confidence
Right.
set of variables that he.
Right. And this is like it's not like it's common in every field and every industry. It's just that the stake at this particular point in terms of forensics is a lot because it's justice. So we need to like fix that part a little maybe.
What were for the findings? What was the correct average for the?
So for machine learning and cryptocurrency, it was 0.87, and for the unit average for the child exploitation cases for the manual part was 0.58. So
Was for child exploitation.
yeah,
Yeah.
so again, so the child exploitation was manual and cryptocurrency was automated. We couldn't get them on the same page because we didn't have like I didn't have the time to like I could have done the same thing where I could have presented my data to different investigators with different levels of experience and done the same experiment, but the results would have been comparable because manual analysis with domain knowledge is going to end up with similar results. So
Right.
yeah.
This is like the what is it?
Hmm.
Last I saw, they were at. I think
So
they were just on the verge of.
right. And I have a story to share regarding like the Facebook facial recognition, and I'll like show you right here.